My dear students, today we are going to discuss the questions of which involve electron affinity. The first kind of question is find the correct order of electron affinity. You have been given four options, so you have to find which is the correct order. So I'm going to discuss two questions now. The first kind of question is you have been given the four options of fluorine, oxygen, chlorine, which possess. You have to understand the concept, then only you will answer these kind of questions. So you have to find the correct order of which is arranged in the decreasing order of electron affinity. So you all know that chlorine, fluorine belongs to the halogen groups. So among other periodic elements, halogen possesses the highest electron affinity, right? Oxygen belongs to the oxygen family group 16. So for halogen, the specialty is that it requires one more electron to complete its octet or noble gas configuration. But we already discussed in the periodic trend bar, fluorine possesses very low electron affinity than chlorine, and chlorine is the highest electron affinity element among all other periodic elements, right? Do you know the reason? I have already written the value. The fluorine possesses 332 kilojoule per mole, the electron affinity. Chlorine is 348 and oxygen is 140. So we can understand the correct answer is this one, right? Chlorine possesses very high electron affinity than fluorine, greater than oxygen. So now we will find why. Due to, first we will consider fluorine and oxygen. Okay. Fluorine and oxygen belongs to the second period. Okay, and the valence electron is belongs to the s orbital sublevel and the p sublevel. The size of both fluorine and oxygen is very less, right? In the case of oxygen, which is belongs to 16 group element, the first element in the 16 group, and after that fluorine. So the atomic number of fluorine is very high, right? Fluorine is 9 and this is 8. So when atomic number, the nuclear charge increases, the attraction on incoming electron also increases. So fluorine, obvious that fluorine across the period electron affinity increases. Fluorine possesses very high electron affinity. That is obvious. In addition to that, the 2p sublevel is very small. This is because due to higher electron nuclear charge, the 2p sublevel and s sublevel is contracted towards the nucleus. In addition, due to the contraction, the inner electron will impact or provide some electron-electron repulsion on the incoming electron. That means when the incoming electron comes closer to the atom, the inner electron will impact some electron-electron repulsion, which will hinder or which will overcome the effective nuclear charge. As a result, the fluorine, the incoming electron approaches to the fluorine does not feel that much attraction from the nuclear charge. Similarly, in the case of oxygen also. So that's the reason why fluorine and oxygen possess very lowest electron affinity. But for fluorine, which require only one electron to complete it octet, that's also overflowed. So that's the reason fluorine possesses very high electron affinity than oxygen, right? Whereas in the case of chlorine, the chlorine belongs to the third period. In addition to 3s to 3p5, this is the valence shell electronic configuration of chlorine. Uh, there is a vacant 3d orbital is there, right? For third period elements, the specialty is that there is a vacant d orbital is there, d sublevel is there. When an incoming electron approaches the chlorine, okay, the electron does not feel that much repulsion from the core electrons. Do you know the reason? Or the valence electron? This is because d pi p pi back bonding. This is because of the reason d pi p pi back bonding and the presence of d sublevel. The d shell is very vacant, and as a result of that, the lone pair, the already existing electrons in the chlorine atom, is donated to the d sublevel. See, I have already discussed about d pi p pi back bonding in one class. This is the p sublevel, and this is the 3d, and this is the p, right? So the lone pair present in the p electron be donated to the d orbital, the vacant d orbital. Also, when an incoming electron come closer to the chlorine, this will accommodated in the vacant d orbital. There is more space available in the chlorine atom due to the presence of vacant 3d sublevel. This is the reason why chlorine atom overcome the electron-electron repulsion, and the nuclear charge of chlorine will attract the incoming one. This is the main reason why chlorine possesses very high electron affinity than all other elements, and among halogen, chlorine possesses very high electron affinity than fluorine. Okay, so this is the correct order. Similarly, we have to consider another question. This is an oxygen family. So you have to understand the concept. Among the oxygen family, oxygen possesses very low electron affinity. Do you know the value, the experimentally determined value is that oxygen is 140, and among that oxygen family, that is group 16, sulfur possesses very high electron affinity. Do you know the reason? The same reason we have already explained. The presence of 3d. Sulfur belongs to the third period. There is a vacant d orbital is there. D pi, p pi back bonding is there. So the lone pair of electron present in the sulfur atoms donated to the vacant d orbital. As a result of that, the incoming electron does not feel that much repulsion from the core or valence electrons. So, and the nuclear charge will attract the incoming electron towards itself. So it can occupy spaces available in the 3D level. So the sulfur possesses very high electron affinity. And the remaining selenium, tellurium, and polonium. This is the general trend. As you all know that across a period, electron affinity increases due to increasing nuclear charge. Down a group, electron affinity decreases due to increasing radium. So the general trend is that down a group, electron affinity decreases after sulfur. But what about oxygen? We will expect oxygen should possess very high electron affinity, right? Because it belongs to the top, it belongs to the position at the top of the group, right? But due to the compact size, due to the small size of 2p sublevel, the income and addition to that, the incoming electron will feel electron-electron repulsion from the already existing core electrons or valence electron. These two facts decreases the tendency to accept an electron. So this is the reason why oxygen possesses very low electron affinity. See the values. Oxygen possesses 140 kilojoule per mole, whereas sulfur is 200. Then across the group, selenium 195, tellurium 190, polonium 185. So among these four options, sulfur possesses very greater electron affinity than selenium, tellurium, polonium, and oxygen possesses the lowest. So the first one is the correct answer, right? Move on to the third question of the same type. So see, this is of the same question of oxygen family we have discussed previously. You have been given selenium, sulfur, and oxygen. You have to find out the correct order. You all know that oxygen possesses the lowest among the oxygen family, and sulfur possesses the highest. So, which one is the correct order? Sulfur possesses the highest, and oxygen is the lowest. So, this one is the correct order, right? So, oxygen less than selenium less than sulfur, right? And what about the fourth question? You have been given four options. You have to find which is the correct one. This is not in the case of order. We have to find which is the correct option. So, fluorine greater than chlorine. The electron affinity of fluorine greater than chlorine, which is wrong. You all know that chlorine possesses the highest among all other periodic elements, the highest electron affinity. So, this is a wrong one. The second, oxygen possesses very high electron affinity than O minus. So you all know that oxygen is a neutral atom. So the electron affinity of O minus means already that atom, the oxygen atom is having one electron. So it is of an anionic form, is already existing a negative charge is there. So electron affinity of O minus, which means the O minus anion, the oxygen in negative charge accept another electron. So it has to overcome the existing electron-electron repulsion, right? The incoming electron will feel the negative charge repulsion, right? So we have to, that is not in energy released, we have to apply some energy in order to accept that electron, to overcome that electron repulsion, right? So this corresponds to EA, second electron affinity, right? EA2. So whether it is correct, we have to supply some energy to overcome electron repulsion to accept another electron. So the oxygen is 140, right? The electron affinity of neutral oxygen is 140. What about this one? This must be very higher, right? So in experimentally it is found that it is 700, approximately 700 kilojoule per mole for O minus. So this is also wrong because in order to get one more electron, oxygen will complete its octet, right? Oxygen require two electrons because the valence shell electronic configuration 2s2p4. Oxygen require two more electrons to complete its octet. So if oxygen require one electron, it will become 1 minus. So O minus will require another electron for completing the octet. So the electron affinity of O minus, obvious that it is very higher than that of neutral oxygen. The third option, neon plus less than fluorine. You know neon. Neon belongs to the noble gas. So it is neon plus a cationic form of neon, which is very unstable because neon itself is a noble inert gas, inert element. So it does not participate in any reaction. When neon plus is formed, which is having a strongest tendency to back to is S2P6 noble gas configuration, right? It has a strongest tendency than that of fluorine. Fluorine is already existing in a S2P5, is S2P5 stage. Neon plus is the actual configuration of neon is S2P6, but in this case it is S2P5, right? It accept the configuration of fluorine. That means neon plus is very unstable and its electron affinity is always very higher. It has the strongest tendency to back to its original state, its ground level. So this is also wrong. This one is wrong, this one is wrong, this one is wrong, right? What about the last one? Fluorine possesses fluorine at neutral state and F minus. Yes, because F minus means this is H2P5. So fluorine has a tendency to accept one electron to complete noble gas configuration. Once it completed the noble gas configuration, whether it has the tendency to accept another electron? No, obviously no. That's the reason why noble gas is having zero electron affinity. So if it possesses noble gas configuration, whether it is having a tendency to accept electron? No, obviously not. So the fluorine, the electron affinity of fluorine minus is zero, approximately zero, because it does not have the tendency to accept another electron. So this is the correct one. Okay, this is the correct one. The last option is the correct one. Let's discuss another question which is related to electron affinity. Electron affinity is positive when you have been given four options. You have to find in which case the electron affinity value is positive. Okay. The first option is oxygen. A neutral oxygen changes to O minus. We all know that the electron affinity, from the definition itself, it is clear that it is the amount of energy liberated. It's moving out. It's the amount of energy released when an atom at its neutral state accepts an electron. So electron affinity process is exothermic. So it is negative in charge. So which is wrong, right? When an oxygen atom is converted to O minus, so it has a tendency to accept an electron, energy get liberated. So it's a system liberating energy means it's exothermic. So it is a negative. In this case, energy release is negative. What about the second case, O minus to O2 minus? So already there is a negatively charged oxygen is there. So we have to, it has the tendency to accept another electron also. So there is, when another electron come closer to this O minus ion, there is an electron, negatively charged electron is there, incoming electron is there, electron repulsion is there. So when an O minus converted to O2 minus, we have to give energy. We have to apply some energy to overcome this. So what is the process according to thermodynamically? Endothermic. So we have to apply energy. So here, the what is the process? Here the electron affinity, the EA2 is positive in nature, the endothermic. Here it is exo. This is endo. And this is positive, right? So we have to check other two options also. What about this one? O to O positive. When an oxygen atom is converted to an O positive one, so it has to give an energy. So this is ionization process. Ionization process. Note, this is a release. This is ionization. This is ionization energy, not electron affinity. Remember, this is not electron affinity because for ionization energy, we have to give energy, which is already endo positive. But the question asking is the question what asked to us electron affinity. This is not the case of electron affinity, right? So this is also wrong. This is ionization. EA always negative. This is also wrong. That is not correct. EA, the first ionization energy is usually negative. The second ionization energy onwards, we have to apply energy. So the correct answer is second one. O minus to O2 minus. That is the correct answer. Okay. Thank you.